Okay, let's get started with today's problem. Today's problem is the day 5. Let's see if we can solve all the day problems. So I got the input and we have a method to just read the input, store it in a variable, right? Just invoke it and just verify if that works, right? So day 5, yeah, we read the input. Now let's go back to the problem and see what it states. So getting started with the problem, right? It states that the North Pole printing document is busier than ever this close to Christmas. While the historians continue their search of this historically significant facility, an elf operating a very familiar printer beckons over you. Okay. The elf must recognize you because they waste no time in explaining that the new sleigh launch safety manual updates won't print correctly. Failure to update the safety manuals would be dire indeed. So you offer your services. Safety protocols clearly indicate that the new pages for the okay, there's a lot of text. Just figure out what we can construct as a problem right in the beginning. So we'll just say we'll just add a doc string which says what we need to do in this problem, right? So um, right, yeah. So we say that the problem somewhat states that won't print correctly, right? Explaining that the new sleigh launch safety manual updates won't print correctly. Okay. Uh, Safety manual don't print correctly. Print correctly. Okay. Now that we know that there is a problem there, failure to update the manuals have some dire consequences. Okay. Safety protocols clearly indicate that the new pages for the safety manuals must be printed in a very specific order. Okay. Print in a order. Alright, we'll figure out what this order is. The notation x bar y, right? X bar y indicates that x bar y, right? Yeah, x bar y indicates that if both page number x and page number y are to be produced as part of an update, page x must be printed at some point before page number y. Oh, okay. Page x must be printed before page y. I think we'll figure it out more. The elf has for you both the page ordering rules and the pages to produce in each update. You can't figure out whether each update has the pages in the right order. Okay. Also it states us each update has the pages in the right order. Right. Okay, we'll figure that part out. Next part is we have a bunch of text and some xy pages and etc and some string. We have no clue of what that's going to be. Fine. If they state that the first section specifies the page ordering rules one per line. Okay, luckily they give an example. Example now states that hey, if you consider 4753, what that means is um, it means if an update includes both page number, if an update includes both 47 and 53, okay, and 53, this suggests that page 47 must be printed at some point before 53, right? 53. Okay, doesn't necessarily need to be immediately printed before 53. Other pages are allowed to be printed. Okay, what this says is between 47 to 53, anywhere between this line I can print 47, right? It just indicates that before 53 47 should be present. Cool. The next section 75, okay, the next section indicates the page numbers for each update, right? So they say that hey, uh, second section indicates the updates, right? Within which we would say that we are stating that because most safety manuals are different, the pages needed in the updates are um, update because most safety manuals are different, the pages needed in the updates are different too. The first update, oh, the lines, each line indicates an update, right? In that case, which says that the first update is I need to update 75, I need to update 47, I need to update 61, 61 and 53, 53 and then 29, correct? Which means that the update consists of page numbers 75, 47, 61, 53 and 29. Cool, right? To get the printers going as soon as possible, start by identifying which updates are already in the right order. In the above example, 75, 47, 61, 53, 29 is in the right order because they state that hey, 75 should happen before. Where is 75? We'll just do a control F and figure out 75. Where do you go sit? Okay, 75 says that I have to come before 53. I think we have 53 in this line. Yeah, okay, 75 is in the right order. Then says 40. So 75 should come before 53 and before 29. Yes, and 61 by any chance? Yeah, 61 also. Cool. So okay. Next problem states that 75, 19, 23. So we have another one, right? 75, 29, 13. So we know that 75 should come before 13, but do we have 29 anywhere over here? Yeah, we have even 29 over here. So this order 75, 29, 13 also is the right order. Correct? Perfect. Correct is correct. That's why the first one is right. The Because the first update does not include in some pages, the ordering rules involve the following missing page numbers are ignored. The second and the third updates are also correct ordering according to the rules, like the first update. They say that the fourth one is not in the correct order. We'll see what is the fourth one. The fourth one is 1, 2, 3, 4, 75, 97, 75, 97, 47, 61 and 53. So we know that 75 should occur before 61 and 53, right? Because 61 and 53. Okay. Um, then we have 97 and 47. It says 97 should occur before 75. Okay, which means you could have 97 before 75, but the ordering given to us here is a bit invalid, right? Because 75 occurs before 97. So this says that hey, that's wrong. Is that their reason too? They are saying that the fourth update is not correct. It would print 75 before 97, which violates the rule of 75 95. Perfect. um cool. um Okay, what are they saying about that? The fifth update is also not correct. Okay, we'll see why is the fifth update wrong. 61, 13 and 29, right? 61, 61, we'll just search for where does 61 sit. 61 says hey, I have to be before 29, which is valid. And 13, what does 13 say? 13 says 29 should come before 13, right? So this ordering is wrong because see, we have 61 coming before 13, which is doesn't matter to 13, but the moment the 29 appears after 13, it's wrong. So if the answer was 61, 29, 13, perfect, we would have said it's valid, right? Okay. Cool. So they have the middle page numbers of are specifically, and so okay, what are they asking us? um, we know which is true and which is right and wrong. The else also needed to know the middle page number of each update being printed. Because you are currently only printing the correctly ordered updates, you will need to find the middle page number of each correctly ordered update. In the above example, Yeah, so now we would be able to say that hey, these numbers should appear before 47, or from 47 you can go over here. My ask here is I would need to convert this to a graph problem where I get to know whenever I reach, I have to first create this mapping which says that which numbers have to appear before which numbers, and then when I process this ordering, I I would need to know, oh, I've seen a 75, um, and nothing else has appeared before it, so it's okay. But when I see a 47, I just need to know, oh, what are the numbers that I've seen before this, right? I have seen 75 before this, so I can just go check who are the elements that should appear before 47. 75 doesn't belong in this list, so that's good. But when I come to 61, right, when I come to 61, um, I'm supposed to say that okay, what are 61s? 61 should come before a 29, and 61 should come before 29. 53, right, 53, and we could say anyone else, 53, 29, 13, 13, right, yeah, 13. So we can say okay, 61, when you come, I've only seen a 75 and a 47, I don't need to worry about this, so I'll move on. When I see 53, I'll be like, oh, 53, who should appear before you? If I have any rule, right, like if there is a rule 53 is on the left hand side, yeah, and it says that I should appear only before a 29 and a 13, then I will say that okay, fine, I've not yet seen these two numbers in my line so far, so I can move on. And then when I see a 29, I can just be like, okay, I've seen a 29, whom should I appear after? Because I could just check, oh, 29 should appear before a 13, or any other values for 29, no, only one, and still it's valid. Let's assume the scenario where this will not hold true, right? Like we will say that what if we cut this whole thing and then say um, we take the invalid ordering just to confirm, does this work, right? They said this doesn't work for 61, 13 and 29, right? So actually we need the 61. I think we just need to remove the numbers because we need the ordering values, correct? Yeah, so 61, 13 and 29. Yeah, so when we say we got 61, 13 and 29, 61, 13, 29, we will say, oh, I saw a 61, I've seen nothing before it, so it's good. When I see a 13, I say, oh, what does 13 need to appear before? 13 is not on my left hand side, correct? Nowhere it's on my left hand side, so it's fine, good enough. When I go to a 29, I ask, hey, who should appear before my 29? 29 says I should appear before 13, but we already encountered 13 in our list, so we could say it's wrong. So um, to do this, if we have this list, right, this somewhat looks like an adjacency list, right, like where we say this, from this number you could go here, we could infer that from this and state that for every number I see on my line, I could just state that if I've seen any number before in my scene which violates this adjacency list thing, I say false. And if I reach the end of the line and everything holds good till then I could say it's true and passes in. Um, Now, could I do better? What would be the time complexity, right? What it might be like, let's say we have um, m nodes in our entire list, right, of page numbers, and they have n connectivities. Like let's say 53 has 2 connectivities, or 47 has 4 connectivities, or rules which say that I should come before those. That indicates that whenever and now the length of the line that we get, right, let's call that as L. Let's say L here is 3. For every element in this I need to go check back, hey element, what is your thing, right? So that will be length into m into n. So if we have 10 numbers with 10 rules, can it be 10 rules? Yeah, it can be 10 rules. 10 numbers into 10 rules, and each line being 10 elements wide. uh, because you could fill it with random numbers which are not belonging to the rules also, right? So then that would be like n cube solution, right? Like where if each one is 10 10 10, then it'll be like 10 into 10 into 10 maybe. right? um, that's probably not the most optimal. um, Initial thought that comes is, could you use like a disjoint set and see, um, could I use a disjoint set? Okay, we'll come to the disjoint set as an improvement, like it's saying that it can be done, but because what this disjoint set would tell us is, who are all the parents. Like 53 is the parent of 29 and 13, right? So we could have a node called 53 and say that I am the parent for these two, and I will have the similarly a node for 29, say 29 is the parent of 13. So whenever I come across a number, instead of me iterating over all my children over here, so let's say when I come across 29, right? If 29 had 13, and let's say we had a number 0 over here, right? 0, I need to check, does it satisfy 13 and does it satisfy 0, right? I think maybe disjoint set doesn't solve the problem here. I still need to iterate over each element and check till now have I seen its children or not in my scene array, right? Um, okay, I think just thinking of it in terms of like a graph problem where we say I have a number, whom can I reach from that number, right? Have I already reached them before? If yes, then that's wrong, right? Like 53 has to come before 29 and 13. And in this example, 61, 13 and 29, 61 should come before 29, but 13 should come after 29, right? Because 29 states that I should come before 13. Okay, so I think we'll just try this solution first, and then we can search for an optimal solution. At this moment, it's not very clear if that's the way, right? If we'll build one, what we'll say build um, rule mapper, right? We'll build one rule mapper where we say that give me the raw data, right? So first, no, we need the rules. Actually, we need the rules, and then um, right, rules is nothing but an array, right? Array which keeps track of from and to, right? Like um, say it should, the source should come first, and then like 53 and 29, 53 and 13, stuff like that, right? So it's a string followed by another string, right? um, and since all are page numbers, can I just call it as int and int, right? Like I'll say I'll pass you two ints in a list, and I expect you to return me a dictionary, right? um, right, so I'll just say okay, from typing import list, right? That works. Next step is I will say and then we'll assume that we build this and return it. Next we will say that validate mapping, validate rules, validate line, right? Like we'll say we'll give you a line, right? We'll give you the line and the rule mapper, right? We'll give you the rule mapper, which is the dict that we just generated above. The line would just be list of ints, right? Because we'll say that for every rule line that we take, we will say that hey, I will pass you int line, right? I think one is sufficient, yeah. And then we would say that hey yo, if this is true, I will return on boolean saying true or false. Return false, uh, true by default. In between I can do a short circuit and say return true whenever it comes. So the how would this story go? Like, so what do I need? I need to convert every line into this, right? For def parse raw data. Okay, what I'm saying is from this queue, we'll check if the logic remains the same. For for element in elements in order mapper, if uh, elements of in order mapper of elem is equal to 0, I'll just add it to the queue, right? I'll just say queue dot append left. I'll just keep appending. I'll just keep appending, and I'll just append what is my element, right? I'll append my element over here, correct? Cool. Now, hmm, now, um, now that I know that I have to get these elements, I have elements with zero ordering, right? I can just say that fixed update, fixed, I'll say fixed update is equal to an empty thing, and I'll say while deck, right? While queue, um, while queue, I can say that while I have a queue, I'll prop out an element, and element will be like queue dot pop left, right? And I will say that for um, pages that can come after, right? What are all the pages that can come after um, in rule mapper, right? In my rule mapper, I have for this page that which I just removed now, I'll be like, hey yo, what is that? Fixed update, right? Fixed update dot append, fixed update dot append elem, correct? We need to append this elem. Now what you're saying is pages after this rule mapper, and you're checking if pages after in if the pages after is in my in order mapper, in my elements to update, right? Because I'm only concerned on elements to update, correct? Pages after in elements to update, then I will check that, hey yo, my current in order mapper, what I'm maintaining for this, right? For these elements, I think the word elements is a bit weird in this pages after minus equal to 1, and then we check if elements to update, elements in order mapper of pages after equal to 0, saying that hey, now this guy can come in. Then in that case, um, q dot append q dot append what, my page, right? Pages after, I think the word page after should make sense, right? And instead of this, if I say page and a lm is not making sense, right? Like to the story, I'll just say page equal to, right? I'll say for all the pages that should come after pages to update, right? Pages to update, right? Yeah, I think that's a better word. I'll just fix everything over here. So I'll say that these are the pages that I should update for with respect to whatever invalid update that you have, given me. And pages in order mapper is, hey, for all of these pages, my one doubt is, should I prepare a new in order mapping based on the data that I have here or not? But we'll figure it out. Um, uh, because that's the only ambiguous part, because for each page, when um, when I get an update, I don't need to check if 75 comes before 100 pages, and for each of those 100 pages I don't need to go check again, right? If my update only contains 75 and 96, why do I need to do that? It's a bit confusing. We'll figure it out. Page, right? I don't want any more elem and stuff, so I'll just say pages in order mapper. Pages in order mapper, yeah, cool. Pages after pages, q dot append page, whatever page after, saying that hey man, this page is now ready to be written. Add it over here. Keep doing this until you have elements in your queue, and once it's done, just say fixed updates dot append append page, right? Fixed update, correct. Append this, beautiful. Fixed updates, get this done. Cool. Somewhat makes sense, but still I feel like this in order mapper might not be valid. Let's see. So we say go from here, add it, and check it and check. Ideal check should be if length of my fixed update, right? If my fixed update, whatever I have, um, if the length of this is equal to the length of my invalid update, right? Only then, because invalid update, only then I should be doing this, correct? I think so. Because you have considered all the elements, right? Only in that scenario you are doing this. We will check if we can do this, right? We'll first run it and see where are we. Where's elements? Where is the word elements in order mapper, right? Pages in order mapper and pages to update, right? Pages in order mapper is equal to this. For every page in order map of the page, for page in pages to update, right? Cool. Run it. Fire the API. What does this say? Hey yo, the mid page sum is 6428, correct? 6428, and the mid page sum is, earlier we had 6034, now we have 6428. Not sure if that makes sense, but wouldn't hurt to try. We'll see. 6428. You know, that's not the right answer. Your answer is too high. If you're stuck, make sure you're using the full data input. Okay, we know that we are too high. If you're stuck, make sure you're using the full input data also. Okay, at least we are certain that over here that we are generating some pages, right? How did this work actually? Len, what would happen actually? How does that work? If I have a list, x is equal to a list of 1 2 3, and if I say len of x is equal to 1 1 2 3, is that work? False, right? Would that work at any point? Can't, right? What does this comparison do in that case? What is it? Len of x is 3. So what if I had 3 elements? I already had, right? It didn't work. 4 elements? No. Then in which scenario did that even pass and enter this fixed updates dot update? Little weird, right? Yeah, we'll come back and check. We shall check. So what are we doing over here? We are saying blah blah blah. uh, wait. Pages to update are oh God. Pages to update. Cool. Pages to update. Now I will say that hey yo, this is the set of pages that I need to update, and these are there in order mapper. I think this is where maybe I should not reuse it. I should create my own listing. Hmm. So what? See, we got 81, 75, blue, 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 blue. This is the same thing that we have to update. Okay, looks okay. See, if everything is 24, 24, 24, 24, correct? How do you think we'll get even 1 0, right? That's quite may not be possible at all. So what we need to say is this in order map or whatever we are preparing over here, right? It cannot be, it cannot have, it cannot look at the earlier rule in order map. We need to prepare it right here. So what we'll say is previously when we said prepare an in order mapper, right? Default dict, and we were doing this, right? I think we can reuse the same piece of logic that we see over here, but right. We'll call this as the pages. So first we will move this to the right direction, right? Yeah. So it says this is no longer default dict, right? Yeah. I think we'll do that. Default dict, default dict, and we'll say this here is an int, right? Cool. Now we will. Oh, what happened? What did I go up to? Sorry. Where am I? Oh, little freaked out. Once again. Once again. Where are we? Yeah. Okay. Um, we have an int. We don't need this now. For page in rule mapper, for every page in my rule mapper, um, right? What I'm saying is create one in order mapping, but page after in page mapper, if page after, if this page actually, if page in pages to update, right? Only then, right? For increment it. Similarly, that makes sense, right? Now you see what would be our page in our pages in order map, right? Pages in order map, right? Makes sense. Rule mapper of the page that you have on. Yeah, I think this makes sense because it's like we're rebuilding the entire uh, we should see some zeros in that case, right? Because so what you're saying is after you do this, you're saying find me the ones with zero, right? Cool. I see here we are only keeping the ones which have the remaining ones you will not increment, right? Because only the ones who have a parent you would do it. You will just check that for pages in um, for pages in pages to update, pages in um, pages to update. Oh, where did I copy that from? Pages to update, correct? Pages in pages to update. If the page of this order is equal to this, yeah, I think this would still work. I'll tell you why. I'll just print the um, page q is q. Cool. Add this and now come back and check. Hey yo, what is happening? If pages are in, what is wrong over here? Pages in order mapper, right? What is wrong with the spelling? Elements in order mapper. Where am I seeing the word elements? That should not at all be there, right? Oh, I think that's the reason the queue never went in. Okay, okay, okay. Makes sense. Pages in order mapper. Fire. Pages after. Page after. Right? Page after. Page after. Fire. Whoa. Am I making mistakes over here? Page after. So you're saying that for every page that should come after my rule page of whatever I have defined here, if the page after is in my pages to update and pages in order mapper of page after, correct? Yes, you're just checking for this page. Holy, this was a very 6305. Last time what it was my answer? Was my answer anytime? Can go check, right? What was my answer? 6305, any chance? But I think last time I got some answer which meant that it was not valid. Check. Oh, that was the right answer. Woohoo! That's right, you're one gold star, closer to finding the chief historian. You've completed day 5, you can share the results. Okay, right, now that this is solved to some point, what is the optimal way to do this, right? There should be some, whatever we did, we go check this, right? For every time when we get an update, we are trying to build an in-order map and check, okay, for that in-order mapping, is that valid page ordering? And then we are printing it. Is there a better way to um, do this, correct? And what is the time complexity? The time complexity for this update operation is right, so we'll be iterating over all of these elements, like that's a O of n over here. For every O of n over here, we will say that we will iterate over, we will go through all the rules. That's an O of m into n, right? uh, let's say there's O of m rules, right? So okay, but m rules might have n pages to go to, so we'll say O of that, this is an O of m into n, right? Of mn, which means this is m into n, correct? And then after that, so it is O of l into this plus O of l into iterating all over the pages, right? How many pages we have? Let's assume we have O of m pages, right? M pages over here. I think we use n for pages, it's easier to keep, right? Like plus O of into n, and in the queue what we are doing is we are again iterating over all the pages, right? It's not triple nested, but it is, no, for every page sub page we are also going, right? Queue. Okay, we are going iterating the queue n, but for every queue page we are again checking the pages, right? So this is an n square, if I'm not wrong. So the entire solution would be what? O of l into m into n. This is a, I think it's an O of n cube solution, correct? Because you're doing all of this. Maybe this is my best guess, is that's an n cube solution, which is not probably correct. See, because we have to go through, it's okay, if n pages are there and l updates are there, then it is l into n square. But okay, I think best option is we'll ask Claude or GPT and see how do you improve this, or is there some scope for changes, right? So what we will do is we'll just copy this first thing, right? We will go to Claude. Where's Claude or GPT, right? um we'll say hello. Where is Sublime? We'll first open Sublime so that we can copy paste this. Copy pasting from set copy mode might not work. Open file. um we will go sort key is update, right? Key x is equal to top or topological order dot get key. Okay, we don't know what is this yet. See, when you say get topological order and I get an invalid update, right? For this update, sorted update key is equal to get this. I don't know. How will that solve actually? When I call get topological order, where am I calling it? I'm just calling it over here and I'm saying that I'll pass you a node. Okay, order. What is order? Order is this one if I'm not wrong. Okay, I'll say that if node in visited, if node in visited, okay, if node in visited, return if visited dot on dfs of add next node order map. Okay, this pre-computed order, probably this just says that I can keep track of who comes before whom instead of finding in order at every time. Okay, does this work? If so, we can sit and see, read this and understand. We'll go check if it works, right? We'll come back to our terminal. We'll just say that we'll see this, right? We'll paste this and we'll see how does that work, right? It says that fix invalid updates optimized and we'll just pass the rule mapper. Cool. um, we'll say hey yo, um, uh, we will invoke the same things, right? Paste it over here and instead of fix invalid updates we will say hey, can you take my optimized method, right? Oh sorry, what happened? Control and optimized, right? And it says give me the invalid updates and rule mapper. I don't need any in order mapper. um, so mid page mid sum, I will take the value and update and see first do I get the correct answer. Is that possible? Let's see if that works. No, right? 6305 is not equal to 6480. Probably, but the thought process is correct, right? Like it's stating that um, give me the topological order. Order is this order map of this. But I think, see, the order 7 appears before 4. If you want, say 75 appears before 63. How will you show that on a number line, right? Or what will your map say, right? In the end of the day, it's nothing but order map says my node here is what, 75. 75 is equal to some order which says that hey, I appear okay, I will probably read more on this and update, but yeah, anyway, so this was today's solution, right? Like the um, solution to advent of code day 5. Yes, we shall do tomorrow's problem. I mean, when we get tomorrow, we'll do that. This was my first attempt at this. Thank you.